All right, lesson 5.3 in college trig. There are sum and difference identities for the cosine function. These formulas will be given to you on a pink sheet. Today we're only going to learn about how to use the first two formulas on this list. I'm going to just kind of show you on the pink sheet real quick here. So the ones on the right are all my difference rules. If you notice, they have the minus sign in them. And on the left side, they all have the ones with the plus sign, and these will be your sums. Okay. And again, you'll be given this sheet even when you take your final exam for trig. Find the exact value of an expression for the cosine of negative 75 degrees. So I know if I was to use the negative angle properties, therefore the cosine at 75 degrees would be the same at cosine of negative 75 degrees. For a second, pretend this pencil is the positive x-axis. If I was to go down here to negative 75 degrees with the red pen versus going up here to positive 75 degrees, both of them would be the x value over the r on the unit circle. Both of them, by the all students take calculus, would be positive. So therefore, the cosine at negative 75 would equal the cosine at positive 75 degrees. Now, 75 degrees in terms of 30s, 45s, and 60s is what we're looking for. We know 75 degrees would be 30 plus 45. Now, using my rule, so my rule right here with the minus, I'm sorry, with the plus sign, my bad. The plus side, it says the cosine of a plus b equals the cosine of a plus the cosine of b, and then that's minus the sine of a and the sine of b. And that's what they've done here. They filled in 30 for each of the a's, so there's the cosine of a, where a is 30, the cosine of 45, where the b was 45, and then it's minus, the sign changes on the word for cosine, sum and difference rule. Then you have the sine of angle A and then the sine of angle B. Now we know our 30, 60, 45 ratios. So we know the cosine at 30 degrees. So 30 degrees, the cosine would be the radical 3 over 2. The cosine at 45 would be 1 over radical 2. Probably don't want to leave that square root in the denominator. The sine of 30 degrees would be from 30 degrees, the opposite over the hypotenuse, which would be 1/2. And the sine at 45 would also be the 1 over radical 2. Don't leave the radical on the bottom. So the first fraction gives me radical 6 over 4. The second fraction is a negative radical 2 over 4. Again, both denominators were the same, and therefore I was able to combine the two fractions. So they asked me to find the cosine of 17 pi 12ths. It is really easier if we go ahead and take our radian angles and to convert those to degrees. A lot of you here have a little bit difficult time figuring out how to use pi thirds, pi fourths, and pi sixths such that you can get a sum or difference to add up to give you the 17 pi 12ths. So in all honesty, it's probably easier just to go ahead and convert this to degrees. So I would take 17 times 180 degrees divided by 12. That would equal 255 degrees. 255 degrees puts you in which quadrant? I'm hoping you were thinking quadrant 3. It would be in quadrant 3 with a reference angle of 75 degrees. Now, ones that are in quadrant 3, the cosine there would have a negative value. So again, we were looking for the angle measure here of 255 degrees. So 255 degrees, I'm drawing a picture here just a second. There would be my angle measure for it. So by all students take calculus, we do know the answer would be negative. So that's where this negative here came from. And then the 75 came from taking the reference angle. Now remember that 255 degrees would be how far off of 180, and it happened to be 75 off of it. So I needed to figure out the opposite of the cosine of 75. Now on the slide before, we had just done the cosine of 75. That was cosine of 30 plus 45. Everywhere there's an A, plug in 30. Everywhere there's a B, plug in the 45. But again, we want the opposite of that final answer. So once we fill those in, this time my answer would be that becomes a negative radical 6 on the top. This one, because of that negative on the outside, the negative here, that's why that's plus radical 2. Now you don't have to, you could right here, you could have typed negative radical 6 plus radical 2. But if you do type it that way, make sure the negative is in the numerator with the 6, not out in front of the fraction bar. All right, a few of the questions are also going to have us go backwards. For example, like I look at this and I'm doing this with a basic calculator. I'm not giving you a scientific calculator for this. So I'm going, wait a minute, cosine of 173 degrees. I don't know that one in my head. That reference angle is 7 degrees. I don't know the cosine of 7 in my head. So here's what I do know, though, is if I go backwards for this rule, now I'm looking for, it goes cosine, cosine, plus sine, sine. So I want cosine, cosine, plus sine, sine. So please take a look at the pink sheet. If you don't have one, please pick one up in class tomorrow. All right, so we want cosine, cosine, plus sine, sine. When I take a look here, let me make it so you guys can see that. All right, there it is. Cosine, cosine, plus sine, sine. See, everywhere there's an A, this A, I'm going to put right here. This is going to equal to the cosine of A minus B. That is what it's equivalent to. So I need to figure out what's the cosine of A minus B, where my A is the 173 degrees and my B is the 83 degrees. So I need cosine of 173 minus the 83. It's going to give me the cosine of 90 degrees. Now remember, on the unit circle, the 90 degrees would be straight up top. 90 degrees would be at the point 0, 1. So 90 degrees would be up here at this point, 0, 1 on the unit circle with a radius of 1. The sine is what we're looking for there. I'm sorry, the cosine. So the cosine at 90 degrees, that would be the value of x over r. So 0 over 1 would be 0. And that's where we got the answer of 0. The directions are telling us to use the cofunctions to find the theta. So we're going to use the cofunctions to find the theta. So my cofunctions, I know secant and cosecant are cofunctions. Since the secant and cosecant are cofunctions, we know those two angles add up to 90 degrees. Therefore, theta plus 62 equals 90 degrees. We subtract the 62 over, and theta is 28 degrees. On problem B, again, tangent and cotangent are cofunctions. I was reminding you over here, your cofunctions. Secant and cosecant are cofunctions, tangent and cotangent, and cosine and sine. And remember, the sum of the two angles would add up to 90 degrees. Now, if it's in radians, 90 degrees is the same thing as pi half, radians, so they could also have to have a sum of pi halves. All right, this one's in degrees. These are two cofunctions, so these two add up to equal 90 degrees. Add the 54 degrees to the 90, and your angle is 144 degrees. Cosine and sine are also cofunctions. So theta plus the 7 pi 6 equals the pi half, because 90 degrees is the same thing as, it's equivalent. Pi half is equivalent to 90 degrees. Now I subtract the 7 pi 6 from both sides, so I basically need 1/2 minus the 7 6. In case you needed a refresher on that, so 1/2 minus 7 6. So if you're going to do 1/2 minus 7 6, now they both had pi's, you would have to get a common denominator. They both need to get a common denominator of 6. You'd multiply these each by 3, so that would be 3 6, take away 7 6. 3 6, take away 7 6 would be negative 4 6, which reduces to negative 2/3. And again, they each did have a pi on those. It says reducing a cosine of a minus b to a function of a single variable. Well, we have write the cosine of 90 degrees plus theta as a trig function of theta alone. In other words, I don't want cosine of some stuff here. I just want one little single thing in there. I don't want the 90 and the theta. So at this point, I'm going, okay, I guess I need to go ahead and use the pink sheet and use the formula. So again, the formula is right here that I'm using. So the cosine of a plus b is going to be cosine a, cosine b, and then minus sine a, sine b. So I'm going to do cosine 90, cosine 0, or sorry, theta. And then minus, and then it's going to go sine 90, sine theta. Now, 90 degrees, remember, that was at the top of the unit circle. So if we have the top of the unit circle, the cosine is the x over the r, and the sine would be the y over the r. So one more time for my unit circle here at 90 degrees. The point would be the 0, 1. My cosine would be the x over r, which is 0 over 1, which would be 0 for cosine. The sine would be the y value there over r, and the y value is 1, so 1 over 1 would be 1. Once we plug those values in, 0 times the cosine of theta would just be 0. negative 1 times sine of theta. That's all I'm left with for my answer. Suppose the cosine of s, some angle s, is 15 over 17, and the sine of some angle t is negative 24 over 25. Both s and t are in quadrant 4, and we're supposed to find the cosine of s minus t. The first thing you'll want to do with this problem is make a picture. So I know they're both in quadrant 4. So I started with angle s in quadrant 4 and t in quadrant 4. So here's a picture of angle s in quadrant 4, and here's angle t in quadrant 4. Now, what I do know is on the first one for s, the cosine of s is 15 over 17. That's going to be my x over r. So 15 over 17. If I did Pythagorean theorem, 17 squared, take away the 15 squared, and then the square root of that, that gave me the y value. All right, over here for angle t. I was told the sine of angle t is negative 24 over 25. Well, the sine is y over r. Again, Pythagorean theorem, so 25 squared minus 24 squared would equal my x squared. So I take 25 squared, take away 24 squared, and then the square root of that. And that's how we get the x is 7. Because again, remember, it's x squared plus y squared equals r squared. Now we're supposed to find the cosine of s minus t. All right, so back to the pink sheet for a second. Cosine of s minus t. The top rule. Cosine of a minus b. It'd be cosine a, cosine b, and then plus sine a, sine b. Well, we do the same thing, except for everywhere there's an a, we're putting an s. Everywhere there's a b, we put a t. Now, the cosine of s, so first off, this is the picture for angle s. The cosine would be the x over the r, so that would be 15/17. The cosine of angle t, now I have to come over here to angle t. The cosine again would be x over r, so 7 over 25. The sine of angle s, go back to angle s, and that's y over r, negative 8 over 17. And then the sine of angle t, come back to angle t again, and the sine would be y over r. So once you plug those in, you'll notice when you multiply the fractions, both of these have 17 times 25. So I already have a common denominator. They make that part of it nice and easy for us. Therefore, then I just need to figure out what 15 times 7 is, add that to negative 8 times negative 24, which gave me a numerator of 297 over 425 for the denominator. This one is definitely on my test. This one is definitely on the final. You need to make sure you study this one and know this one well when you do the homework. Please understand it. Know how to do it from the top to the bottom. That'll end our notes today for 5.3. Please make sure you do the multiples of 4 tonight on this lesson before you come to class tomorrow, because tomorrow we'll be doing 5.4, which will be more sum of difference identities, but it'll be for sine and for tangent tomorrow. Thank you guys. Have a great day.